Hello YouTubers. I ran a MaxEnt analysis on the UFO presence points from the previous videos. Unfortunately, I couldn't add the last 2 years of data. Upon closer inspection, there wasn't no latitude and longitude coordinates. That said, there's over 40 years of data on these reports. For background rasters, I use the current 2.0 2.5 minute scale BioClim rasters, which has an average of several temperature and moisture variables from 1970 through 2000. One small issue is that it doesn't cover 2000 through 2017. There's a package in R to develop BioClim data, however, so I'll probably explore that in a future video. I could have removed the presence points from 2000 through 2017, but I felt it was more important to include the presence points than to exclude them. Since the rasters cover the whole world, the first thing I needed to do was clip them to the spatial extent of the United States and Canada. This meant a few of the points weren't included in the analysis, but the vast majority were. I used Model Builder to create a simple tool that iterated through the folder containing the rasters and clipped each one to the spatial extent of a tiger line shapefile of the United States and Canada. Since I was using the standalone MaxEnt software and it doesn't accept TIF files, I had to convert them to either BIL or ASCII format, and I went with ASCII. I just made a new tool to do that. It could have been done just as easily with one tool, but I like modularity, I guess. Since the BioClim data already had the same cell size and spatial extent, there was no need to perform any other editing. For the presence points, I had to create a CSV file with 3 headers, which are namely species, longitude, and latitude. So I opened a new Excel file and copy and pasted the attribute table into Excel by saving it as a text document, then opening the text up with commas as a delimiter, removing everything but the longitude and latitude values, and inserting UFO for all rows under the species column, then saved it as a CSV. After that, I just opened the MaxEnt bat file and input the CSV along with the folder that contained the ASCII raster data. I also set up a couple of options for reducing the size of the testing and training pixels on the output map so that you can see the probability distribution, and I checked the option for creating response curves and doing a jackknife for variable contribution. So here are the results, which I've made available at the download link in the description. All you need to do is unzip the folder and open the HTML document. And this is what the results say. For the analysis of emission/commission, the emission rate should be close to the predicted omission. So the blue-gray line should closely match the black line. As you can see, it very closely matches. On the ROC curve, the closer to 1 the training and testing data are, the better the model is at classifying the presence data according to the background data. Both the testing and the training data have fairly high value of 0.879 and 0.876. Here's the probability map that was created. White dots show the presence locations used for training, while the violet dots show test locations. Since I haven't removed correlated variables, it's not really worth mentioning the response curves, and variable contributions should be taken with a grain of salt. It will be interesting to see how the models change with correlated variables removed, however. I'll show you how to remove highly correlated variables easily using R in the next video, then run another model. In the video after that, I'll use the Biomod 2 package on the same data and compare several types of models, including random forests, MaxEnt, logistic regression, and multiple adaptive regression splines. There's a link in the dataset in the download description. With that said, the analysis of variable contribution shows that Bio 11, which is mean temperature of coldest quarter, contributes the most to the model at 61.6%. What's interesting is that the jackknife of variable importance shows that Bio 1, which is annual mean temperature, has the most useful information. It only contributes to 2.2% of the model. That's likely due to the variables being correlated, but we'll compare models in the next video. Thanks for your time. If you liked this video, please show your support by subscribing. And if you really like the video, share it. Thanks once again.